Good evening, all of you. Welcome to our session. So, in this session, let us learn the line drawing algorithm DDA algorithm. So, DDA means digital differential analyzer. Screen in our computer graphics, the screen consists of all the pixels. So, our screen is nothing but a collection of pixels. So each pixel can be represented by using x comma y. Every pixel can be represented as x comma y. So here we will have the first point, starting point and ending point, and this algorithm is used to find all the intermediate points, that means the pixels. So this algorithm is used to find all the intermediate pixels in between the starting point and ending point. Now, as we know, the line formula is y is equal to mx plus c. Here m is nothing but a slope, which is y2 minus y1 by x2 minus x1. This slope is for x1 y1, x2 y2. So let us have a general formula. So y2 can be replaced with yk plus 1, x2 can be replaced with xk plus 1, y1 is replaced with yk, x1 is replaced with xk. So if the 2 points are xk comma yk and the next point is xk plus 1 comma yk plus 1, then the slope is yk plus 1 minus yk by xk plus 1 minus xk. Now let us derive the points. So m is equal to yk plus 1 minus yk by xk plus 1 minus xk, where xk, yk are the present points and xk plus 1 and yk plus 1 are the next coordinate points. So we have to find all the intermediate points from starting point to ending point. So we will start our algorithm from starting point. So we will find the next coordinate and then next coordinate and then next coordinate. So we will continue the same procedure till we reach the end point. So whenever we get the end point x comma y, then we will stop the algorithm. Here in this DDA algorithm, we have to remember the 3 cases. Case 1. First we have to find out the slope in between starting point and ending point. M is equal to slope between starting point and end point. Now, depends upon the slope, we will have the 3 cases. Case 1, m is less than 1. Case 2, m greater than 1. Case 3, m is equal to 1. See, in our computer graphics, as we say that the screen consists of pixels, so complete screen consists of pixels, collection of pixels. If m less than 1, then the x coordinate will change in unit intervals. If m greater than 1, y coordinate changes in unit intervals. If m is equal to 1, x and y changes in unit intervals. So obviously, if the screen is collection of pixels, it will be in unit intervals. So here this indicates xk plus 1 is equal to xk plus 1. Here y is unit interval, so yk plus 1. Next point, next coordinate is changes in unit interval. So yk plus 1 is equal to yk plus 1. Here xk plus 1 is equal to xk plus 1. Yk plus 1 is equal to yk plus 1. So we should remember that here k plus 1 is a suffix. Here xk plus 1. Xk plus 1 is different from xk plus 1. Here, as it is a unit intervals, both are equal. And what about the y? So we had xk plus 1 and we need to find out the yk plus 1. For this, we know the slope m is equal to yk plus 1 minus yk by xk plus 1 minus xk. As this becomes 1 because xk plus 1 is equal to xk plus 1, so that xk plus 1 minus xk, so xk cancel 1. So we will get m is equal to yk minus m is equal to yk plus 1 minus yk by 1. From this equation, we can get yk plus 1 is equal to yk plus m. So if slope is less than 1, x will be moving in unit intervals, y will be moving in slope difference. Here similarly yk plus 1 is y coordinate is moving in unit intervals. So let us calculate the x coordinate. So yk plus 1 minus yk by xk plus 1 minus xk. So here y moves in a unit intervals, this complete equation becomes 1. So this equation can be written as m is equal to 1 by xk plus 1 minus xk. So xk plus 1 minus xk is equal to 1 by m. From this, xk plus 1 is equal to xk plus 1 by m. So y coordinate changes in unit intervals and x coordinate changes with 1 by m of x coordinate, previous coordinate. Here the x coordinate will be unit interval and y coordinate will be changes in slope. Here the coordinates are xk plus 1, yk plus 1. So based upon these formulas, we will find out all the intermediate points. So once again, let us look. So depends upon the slope between starting point and ending point. If m is less than 1, the x moves in unit intervals. If m is greater than 1, y moves in unit intervals. And if m is equal to 1, both the x and y coordinates move in unit intervals. So here the x moves in unit intervals means the next coordinate will be the previous coordinate plus 1 unit interval. That means x coordinate, previous coordinate plus 1. Here we have considered xk and yk as a present coordinate, xk plus 1 comma yk plus 1 as a next coordinate. So next coordinate will be xk plus 1 will be previous coordinate plus 1 unit intervals. Similarly, the next y coordinate will be present y coordinate plus 1 unit intervals. So from this formula we have m is equal to yk plus 1 minus yk by xk plus 1 minus xk. Here in this case m less than 1, we know that xk plus 1 minus xk, that means the next coordinate minus the present coordinate, this always will be 1, because here we can substitute xk plus 1 minus xk. So this can be written as xk plus 1 minus xk. So xk will get cancelled, so 1. So from that we will get m is equal to yk plus 1 minus yk by 1. From this equation we can have this next coordinate yk plus 1 is equal to yk plus m. So our next y coordinate will move with the difference of slope. So next y coordinate will be present y coordinate plus the slope. Coming to this case, y will move on unit intervals. That means next y coordinate will be present y coordinate plus 1 unit interval, so 1. And from this equation m is equal to yk plus 1 minus yk by xk plus 1 minus xk. Here y moves in unit interval, so here numerator will become 1. So 1 by xk minus xk plus 1 minus xk. From this equation we can find out this xk plus 1 next coordinate. So xk plus 1 is equal to xk plus 1 by slope. In this case both will move in unit intervals, so xk plus 1 next coordinate will be 1 added to the previous coordinate, yk plus 1 next coordinate will be 1 added to the present y coordinate. So from these formulas, from these three cases, we will calculate all the intermediate points in between the given starting point and ending point. Now let us have a brief look once again after calculating the slope m. If m less than 1, x changes in unit intervals. If m greater than 1, x moves with deviation, y moves in unit intervals. Xk plus 1 comma yk plus 1 is equal to xk plus 1 by m comma yk plus m. If m is equal to 1, x and y moves in unit intervals. That means xk plus 1 comma yk plus 1 is equal to xk plus 1 comma yk plus 1. So for this we have to calculate, first we have to calculate the slope between starting point and ending point. If m is less than 1, x changes in unit intervals. So there will be some deviation on y moves. So we have to calculate the next coordinate of yk plus 1. That is equal to yk plus m, as I have shown in the derivation. And if m is greater than 1, that means the slope is greater than 1, then x moves with some deviation and y moves in unit intervals. So that we have to find the next coordinate of x. So xk plus 1 is equal to xk plus 1 by m, comma, yk plus 1, because y moves in unit intervals. And if m is equal to 1, x and y both will move in unit intervals. So xk plus 1 comma yk plus 1 is equal to xk plus 1 yk plus 1. So let us have an example. Now let us see one example. So we have to find all the intermediate points in between 0, 0 and 4, 5. So the starting point is 0, 0 and the ending point is 4, 5. So that we have to find out all the intermediate x and y coordinates. So first we have to calculate slope. Y is equal to 5 minus 0 by 4 minus 0, that is equal to 5 by 4, which is greater than 1. So here if m is greater than 1, y moves in unit intervals, x moves in xk plus 1 by m. So xk plus 1 comma yk plus 1 is equal to xk plus 1 by m comma yk plus 1. Xk plus 1 is equal to xk plus 1 by m. Yk plus 1 is equal to yk plus 1. So for this we have to calculate 1 by m. We have to calculate 1 by m. So here m is equal to 5 by 4. So 1 by m is equal to 4 by 5. It is 0.8. Now let us see x coordinate, y coordinate, x plotted on the graph, y plotted on the graph, and the coordinate axis x comma y. So we have to start from 0, 0. So x is 0, y is 0. So plot the 0 point, y 0 point. The first point is 0, 0. Coming to the next point. So here m is greater than 1. Y moves in unit interval. So y becomes 1. And x becomes the old coordinate plus 1 by m. That means 0 plus 0.8. So it will be the pixels. So we can say the pixel number 1 or pixel number 2, but we can't say the pixel number 0.8 pixel, 0.5 pixel, 0.6 pixel. So decimal part must be round up. So here we have to round this decimal. So if the decimal part is greater than or equal to 0.5, then we have to apply ceil function. Ceiling function. Ceiling function means we have to round to the upper value. If it is less than 0.5, we have to apply flooring function. Flooring function is lower value. So just like we can remember like ceiling and flooring. Ceiling will be in the top, so we have to round up to the upper boundary. Floor means flooring, the bottom one, so we have to round up to the lower boundary. So the actual value is 0.8, but while plotting in the graph, we have to round up. So it is greater than 0.5, we have to round to the upper boundary. The next point will be 1, 1. Now, the next point will be y moves in the unit interval, so y becomes 2. X moves with 1 by m difference, 0.8 plus 0.8, so 1.6. So y plotted will be 2 and x plotted will be rounding. So it is also greater than 0.5, so we have to round to the upper value. So 1.6 becomes 2. The next point will be 2, 2. Again, y moves in unit intervals, so 3, y becomes 3. X coordinates with adding 0.8, so 1.6 plus 0.8, 2.4. So 3 will be plotted in the y, and coming to the x plot, here the value, decimal value is less than 0.5, so we have to apply the flooring function, so it will be rounded to lower boundary. So the value, the point plotted is 2, 3. Again, the y value is unit intervals, x value adding 1 by m value, 2.4 plus 0.8, it becomes 3.2. Again we have to round up, y point will be plotted as it is, 4 will be plotted in the y, and 3.2, here also the round up function, we have to apply the round up function, it is less than 0.5, so we have to apply the flooring function, that means we have to round to the lower boundary, that means 3. So next point will be 3, 4. So once again y is moving into the unit intervals, y becomes 5 and x is adding 1 by m, that means 4. So obviously it is a round up, so 4 is plotted on x, 5 is plotted on y, the point will be 4, 5, which is the end point. So here we have to stop this DDA algorithm. So the points of a line are 0, 0, 1, 1, 2, 2, 2, 3, 3, 4, 4, 5. So these are the intermediate points in between 0, 0 and 4, 5. That means these are all the 4 pixels in between 0, 0 pixel and 4, 5 pixel. And the main disadvantage of this algorithm is we have to apply the rounding function, because we can't plot the decimal part on the screen, so we have to round up to either lower boundary or upper boundary. That depends upon the decimal value. So that is the main drawback in. So let us stop here and we will see the Bressenham's line drawing algorithm, which avoids the drawback of DDA algorithm, that means a rounding function, in the next session. Thank you.